Here we are again. This is the fourth lesson in a series of lessons designed to help you learn how to program using the Prograph visual programming language. Where we left off from the lesson 02, we had created a huge variety of different operations that can be placed in the case of a Prograph method. In this particular lesson, we want to discuss a bit more in detail what's going on with the various controls. So in order to do that, I'm going to just start with a clean slate, and I'm going to go back to my classes, and I'm going to create a few more methods. Let's call it thing 1 and thing 2. Only method 1 and method 2. And let's sort of see what they can do. What are we going to do? Let's make method 1 be a method that sets the name of my class instance. So, in fact, let's call it set name rather than method 1. Well, let's do something. Call this get name now that I'm thinking of it. And this one will look something like this. And I'm just kind of running through here. Oh, it's a little too insensitive there. There we go. Okay, so we've got a few methods created for my class, and you know what? Let's have my special class have those same methods as well. And we're going to talk briefly before we get to controls, and I promise we'll get to them. We're going to talk briefly about a context-driven method. So let's say we're going to create an instance of my special class. The flash means I've been saving. And we're going to call set name. And we'll call it Tony. Alright, well, I'm going to do a Command-Shift-D and just execute it. Let's see what happens. So I've created an instance of my special class, has the name Tom. And I'm going to hold down the Command and down arrow to step in, and sure enough, we're about to set the name attribute. Now notice that we are in the set name method of my special class. But this is exactly like the set name method of my class. So rather than duplicate that functionality, what we might want to do is have my special class simply call its parent's version of set name, and then maybe it'll do something a little different. So how do we do that? How do we get this method to call the parent method? Well, what we can do is create a context-driven method operation. And as discussed briefly in the last lesson, you put 2 slashes there. And we'll connect it up. Now, if I were to run this, it would call itself forever. In fact, maybe we ought to demonstrate that. I'm going to close up shop. I'm going to do a Command-Shift-D. We're going to go in here. And context works this way. The thing that came into the method sets the context. So the context is my special class. And now a context-driven method is going to say, I'm going to call the setName method of whatever my context is. And the context is my special class. So let's go in. Whoa, Nelly, we're back in there again. Let's do it a third time. And so you can see this would just go on forever, and it wouldn't actually, it would lead to a crash after some point. This is not what we want. We want it to call the setName method of the parent class, which is my class. So first of all, we're going to get out of this by backing up, and I'm just going to command click on the setName operation over here, and we've rolled back. We can bring up the stack, and we see we're back here. Just to show you the stack real quickly, I'm going to do the command down arrow, and we'll just keep going in here a few times. And if I go and bring up the stack, I'm now pretty deep into the calls to the setName method. I can also see the stack over here by holding down the command key and clicking on the icon. I can go back up to, say, this version, and if I do a command click on the operation, it will roll everything back, and now my stack, I'm back upstairs. So let's back up a little bit further and just get back to the input. We've executed the input operation. There's my instance of a special class, my special class. There is what we're going to set the name to. But this isn't doing what we want. We want it to call the parent. So I'm going to double click to bring up the code. I'm going to select this, and now we're going to get to our first control annotation. If I go over here, I see on the second line down, super. If I select that, you'll see a little arrow shows up here. Just do a quick save. And now let's see what happens. I have an instance of my special class, and I have Tony. The context is my special class. And what the super annotation does is it says, whatever this method is, call the parent method or super method, the method in the parent class, when you execute this operation. So now I'm going to hold down the command key and the down arrow. We're going to step in. Oh, and look what happens here. We are not coming back into the setName method of my special class. Instead, we are now in the setName method of my class. This is exactly what we want. So now we've set the name attribute, and what we might have wanted this special setName to do for my special class is maybe get the name and then add a little extra text to it. And maybe what we really want to do for my special class is update the name after we got it. So we called the parent method setName, which we know deep inside just sets the name attribute. And then we're going to get it, and we're going to add a little text to it and update it by setting it. Now, we want this to happen before that. Prograph's data-driven. There's nothing in here that explicitly says this has to happen before that. We could have gotten the name first and then set the name, and that would have not been what we wanted. We can enforce an order of execution when there's ambiguity by using what's called a synchro. Now, you won't find synchro up here anywhere. You have to sort of know, just like in clicking and connecting, just what to do with the mouse and the keys. If you select an operation and hold down the Option key, you will get a series of semicircles. These indicate temporal flow, a direction of execution. So if I go over here and click, I have now placed a synchro between this operation and that operation. This will happen before that. So if we go back here, we see that it happens in the order we want. So whenever you feel you need to explicitly set the order of execution, you use synchros. And it's a very similar type of technique. To connect something up in terms of data flow, you select the root or terminal and hold down the Option key. And to enforce temporal order, you select the operation and hold down the Option key. Then you click on the target. Okay, so we got the name, which is now Tony. We're going to add a little bit of text to it. Tony is the name. Well, that's no good. Let's back up here. I'd like a space in there, so I'm going to enforce that with some quotes. Again, the beauty of Prograph is that you can always back up and change data and edit your program as it is running. Now let me take a look. Tony is the name. That's now the new name. And we're done. So I'll click one more time. The key here is that this is our first control annotation. We have taken an operation and we have annotated it with some control information, and in this particular control in terms of execution of your program, and what we wanted to control is which method was called. We wanted to call this super method, and this is a typical pattern in Marten. When you want to call a super method, you generally always call it in the form of a context-driven method. Okay, well, let's do a little bit more with this. Let's delete some stuff here. Let's illustrate some control in terms of which case do you execute. Let's say we really want the name to be Adam. And if it wasn't Adam, we want to do something else. Well, I'm going to duplicate this case. Using the left and right arrows, I'm going to navigate to the second case. Now, for purposes of screen real estate, you go between cases by using the left and right arrow keys. You may also double click. There is a technique where you can open up each case in a separate window, but we generally advise against it because before too long you've run out of room. In the second case, what we want to do here is we're going to say, you know what, if the name wasn't Adam, we're going to set the name to Adam. So I'll change that into a set operation, and now we have our case set up the way we want. Let's run through the logic of this. This is pretty much an inflexible set name method. It's going to set the name, but if the name is an Adam, it's going to set the name to Adam. So let's give this a try and see how this works. Command-Shift-D, start running it. Command down arrow to step in. It's going to set the name. The name is going to be Tony. And it is not going to satisfy the criteria of this match operation. So let's talk again about this kind of control annotation that takes you from one case to the next. Every operation in Prograph either succeeds or fails. Now, that's based on the logic, generally, of the operation, and consequently, an operation like input bar always succeeds There isn't any way for it to fail. The same with creating an instance of a class. Always succeeds. And in fact, pretty much everything always succeeds except for match operations and potentially primitives like show or some other kind of primitive. Here's an example. Let me bring it up and say equals. Let's see, I think that's a primitive, and this primitive is going to either succeed or fail. These are generally the two kinds of operations that will really succeed or fail. Most everything else is going to succeed. By the way, if you kind of wonder what equals does, you can double click it. It will show you where it is in the code, and it will also bring up some documentation that you can read about what's going to happen when you execute this operation. Remember, primitive is an operation that supplies the basic functionality needed to get a program up and running, things like plus and minus and so forth. Well, let's see what happens here. Let's back out, go back to our running code. I'm going to hold down the command key and hit the down arrow. That is going to execute the match, but the match is going to fail because the input is not Adam. So let's see what happens here. Holding down the command key and hitting the down arrow, why, it vanished. And what you are in right now is kind of an intermediate step of debugging. You have actually kind of backed out of what you were attempting, which was to execute this method. And if I hold down the command key and hit the down arrow one more time, it takes us back into that method operation. But now we've gone to the next case. So that's one thing that you can do with the step into functionality, is when something fails and you're directed to go to the next case, it will take you in there if you hit that key again. So now we have finished up here. If I examine what is the state of my instance of special class, the name is in fact Adam. Well, let's just take another look at this. And let's go back to equals so I can play around. What are the possibilities here? All of the logic in terms of going to the next case or stopping or starting and so forth are contained in these 5 symbols. Right now, the square without any additional lines drawn in it means that you go to the next case. Now, you can go to the next case if the operation succeeds, and you can go to the next case if the operation fails. Failure is indicated with an X, and success is indicated with a circle. And just to illustrate that, let's see what happens if we change this to go to the next case on success. Well, let's run it. We go in, we set the name. Is the name Adam? No. What's going to happen here? Well, this says if the match of the name is Adam, then go to the next case. But, of course, it doesn't match Adam, so the operation is not going to succeed, and we just keep executing this case. Let's try it again. Suppose I change this to Adam, though. All right, now we're sending Adam to Adam, and this match operation is going to succeed. Adam is the same as Adam, and so we're going to go to the next case. The way to see that in the debugger is hold down the command key and the down arrow. We come out, we go back in, and there we are. we have two different versions of this method. I'm going to take the version that is in my special case. What are the other things we can do? Continue, terminate, finish, failure. Continue is an easy one. This basically says no matter what happens, just keep rolling along. So what I'm going to do is I'm going to change this back to go to the next case if the match does not succeed, which since we're putting in Tony, it won't succeed. And we saw before that would take us to the next case. Let's just illustrate that real quickly. It's not gonna match, therefore on failure, and this is gonna fail because they don't match, go to the next case, out and back in. Sure enough, we're in the next case. But now let's back up and change this to a continue control annotation. And basically this says regardless of what happens, just continue. So it's not going to match, it's going to fail, but this says continue on failure, and so we don't go to the next case. It's fairly rare that you actually use the continue control annotation. Now terminate, what in the world is that about? Let's put something down here called show, and we're going to call this didn't terminate. And I'm going to put a synchro in here. I want the match to be performed before the didn't terminate. One thing you can do to see the execution order of your case is to select something and then start hitting the tab key, and it will highlight in red the operations in the order they will be executed. Okay, so we definitely are going to execute the match operation before the constant operation. Let's see what happens here. Okay, Command Shift D. Well, we didn't see very much. Let's go in here. In fact, I'm going to set a breakpoint on this so that we never miss out. Okay. Actually, I'm going to get back to that. All right, we're going to set the name. The name is not Adam. Therefore, this is going to fail. If it fails, we're supposed to terminate. Terminate is a control annotation that says immediately stop all execution, period, no exceptions. And that includes executing the output operation. So generally, you do not ever want to put a terminate control when you are supposed to output something, because it will not execute the output bar. There can be some handy tricks for that, but you need to know what you're doing there. So, the name is not Adam. This will fail, it will terminate. By terminate, it means we won't do this operation, we won't execute that operation, we won't execute the output bar operation. To see what would have happened if it didn't terminate, just to kind of give us a context, I'm going to hit the tab key and skip over execution of the match. Now we're going to execute the constant operation. We're going to execute the primitive show. That's going to come up and so forth. Well, let's back up and try it again. I put in a breakpoint, so we just stop. Now, we demonstrated that a little window will come up saying didn't terminate if this didn't terminate. It didn't terminate last time because we purposely skipped over it, but now we're not going to. I'm going to hit the return key, which will execute this method, this operation rather, this match operation. It will fail, it will then terminate, and none of this will get executed. Let's see if that happens. I'm going to hit the return key, and bam, we're out of there. So that is the terminate operation, terminate control annotation. Well, what's failure? What's that all about? That's like terminate, but what we saw happen last time we did this is that this operation actually executed. What happened on the inside was that all of this stuff got skipped, but the operation still executed and succeeded. And that's a very important point. It succeeded. If I were to type set name in again, let me type my special class set name. Notice that once I type it in, we now see a square indicating a control annotation, which is going to take us to the next case. That's automatically put in for you by Marten because it knows that inside there is the possibility that this operation will fail. So as we stated before, every operation can either succeed or fail. And some of the basic ones that have this property are the match, are some primitives. But another type of operation that can succeed or fail are methods that you yourself create. And the way you make them fail is by putting in a match or some other operation that you put a fail annotation on. So what's going to happen now is we're going to come through here. Tony is not going to equal Adam, therefore this fails. This doesn't match, and when it doesn't match, it's going to fail. And what that is going to do is it's going to tell the engine, hey, this operation failed. What do I do if it fails? So I need to annotate it by saying, you know what, if it fails, go to the next case. Using the arrow key, we'll put this up here. We'll just say failed, exclamation mark. Okay, let's get back to this. Let's execute it now. Okay, I set a breakpoint. The name is not Adam. It's not going to succeed, and the fail annotation is going to cause this whole set name operation to fail, which then says if it fails, go to the next case. Let's see what happens. Bam! Everything shut down, and we immediately went to the next case, and we're going to tell everybody that it did fail. So that's the failure control annotation. There's one more called finish. And to discuss this, we need to discuss repeats and loops and lists, and we'll do that in the next lesson.